Okay, good afternoon, everyone. Nice to see you all here. Let's get rolling right away. So, annotating data the right way. A little bit about myself. I'm a data scientist and developer at Booking.com. I've been coding professionally for the last 15 years or so, and for the last 8 years, I've been working with Python on machine learning and NLP problems. And today, we're going to talk a little bit about annotations and how to do them right. So, I hope to convince you that you should think carefully how you start an annotation project and how you create it, then how you scale it further internally within your company with internal annotators, but also externally with mass annotation services. And in addition, we will talk about the common case of having unbalanced data and how to handle this using active learning. So the setting that we will use in order to provide examples will be the setting of a chatbot that we have at Booking.com. You can try at Facebook Messenger at Booking.com and try to book a room with us. And in this chatbot, we are trying for one of the problems that we have is that users might ask us questions like, is this hotel has free cancellation policy? And we would like to identify the topic and, of course, provide the right information for the users so they can book with confidence. So basically, our setting is text settings and it's text classification. I would like to stress that this kind of guidelines are applicable not only to text, but also for images, videos, medical records, whatever you need, whatever data that you take humans to label, and humans have varying opinions, and you should probably take this into account when you're doing an annotation project. Come and join us, everybody. Yeah. So just quickly repeat that the setting is text chatbot, but these guidelines are not applicable only to text. And we will start right away with understanding the first step in an annotation project is deciding whether we should really do this. It's very expensive to annotate. It takes a lot of human time to just go on and label each example. And you need to think whether you have cheaper options that you can utilize. For example, external data sources or unsupervised learning, some kind of heuristics. Maybe you can get like 70% accuracy on whatever problem that you need to tackle. And that 70% accuracy is good enough for your product. And you should push it to your customers right away and see how they interact with this machine learning model or even like simple regular expression model. And then you will learn a lot more whether you need or not better performance or accuracy. So think about this. Also, many times you can deduce the label from the user's behavior. So if you have a ranking problem and you recommend some item, if the user wants this item, then it's a positive label. If they don't want this item, they didn't bought it, then it's a positive. Then it's a negative label. And you can deduce it without annotating. However, in many cases, we do need to annotate. Sometimes the problem is very specific or complex. Like in our cases, we have a lot of different types of information we would like to provide the users with, and there is no external data source. Also, we have a very weak feedback loop. So someone might ask us basically if the hotel is wheelchair accessible, and we would answer, I'm sorry, but it's not. And then the user would not book. It doesn't mean that we didn't get the label right. It just means that this hotel does not suit the user. So we can't really deduce it. And the bonus of annotating anyway is that you get in-domain quality data for your product. And usually when you think, what should I invest my time in? Getting more in-domain quality data or having a better, larger neural network, more complex model, domain data beats it by far. So that's a bonus of annotating. So we decided to annotate, but the first thing we need to do is explore our data. Maybe you think you know like what kind of labels you need, but until you get a real feel for the data, you might change your mind. So use some kind of a flexible tool. I use Google Spreadsheets a lot for this, but whatever thing that works for you is also fine. And try to kind of annotate the different examples that you see. Try to change the labels as you go. You might think that one category is very dominant, but when you look at the data, you see that it's not that common, or another category which you didn't think exists at all seems to be very dominant in the data. So change the labels, try to explore your data, understand what kind of categories or labels you need, and then create some kind of initial guidelines of what are the categories that you need. After you create your categories, you need to define the labels very specifically. And I would like to really explain why clear boundaries are crucial for you. Because let's take this example, no understand poquito inglés. Let's assume that your task is understanding whether this sentence is in English or not in English. What would you do with that? Who would say this is English? Please raise your hands. Okay, interesting. I would think it's still English. Someone tried to talk English with us without much success. But the different views cause the data to be noisy. If half of the annotators will use one label and the other half will use another label, then the data set would be very noisy. It will be very hard to generalize this data, and your machine learning performance would be suboptimal. So try to write down the guidelines as you go. Whenever you see an example like this, which you need a minute to think about, copy it to your guidelines and elaborate why you choose one label or the other. Try to really set clear boundaries in order to get real clean data. There is no other way. In addition, your labels should reflect whatever actions you're going to take in your product. So for example, let's assume that we have a different action for showing room facilities and different action for showing hotel facilities like swimming pool. And we don't want to show both to the user. It's a lot of data. We just want to show one of them depending on the question of the user. So I will use different label for each kind of sentence. Either it's a question about room facilities or a question about hotel facilities. I would not use some kind of abstract category like facilities, because then I will have to insert another model or another decision in between, which makes all my evaluation, all my testing very, very indirect. So I don't know if my model is good because I have another thing that needs to decide after my model decides what is the label. So try to stick to your actions when you're annotating, and try to stick to your near-term goals in the product. So let's assume we have a topic of transportation. A lot of people asking us, how do you get from the hotel to the airport? There is a metro station nearby the hotel? That's a lot of good questions, but maybe I don't have the data right now to answer these kind of questions. So I don't need to annotate them like rigorously. This is the label of walking distance, and this is the label of airport transportation, and so forth. I will just get a big bucket category of transportation, put everything there. If the user asks about it, I will say, well, we do not support it right now. But do not waste the brain power of your annotators to really do this and get some kind of perfect labels for things you're not going to use right now. Probably when you'll get the data and support transportation, you will have different ideas about what kind of categories you need, and you will need to revisit and change the annotations anyway. So don't waste your time and others' time on this. Okay, so right now we kind of finished the first quarter of the presentation, understanding whether we should start an annotation project, exploring the data, creating some action-minded annotation scheme. And at this stage, you might have already a few hundred examples annotated by you because you were working on the data. And it might be a good time to stop, because maybe you can train some kind of model which has adequate performance, and it can be pushed to users and see how it affects them and if it helps them at all. And you might be surprised, but that's an important thing to do. You do not always need to strive to get the best accuracy just before you push it to the customers. Try to use the model in production as soon as possible. So possibly there is no need to continue, but if you do want to continue, let's have a short intermission on annotation tools and how to construct them. So in the past, at least in the linguistic community, annotation tools were horrible. I'm sorry if someone have ever worked on BART, which is the screenshot, but you need to understand very thorough linguistics in order to annotate part of speech tagging, dependency parsing, constituency parsing, lemmas, everything. Each such sentence took a lot of time to annotate, a lot of training, and it was very hard to change later on. This kind of annotation is really not scalable very easily. I would advise you to use simpler tasks and one annotation at a time. So the screenshot here is coming from a tool called Prodigy. You can see in the middle the text that we need to annotate, and then on the title, the label of artificial intelligence. And the annotator basically has only 3 options. Either accept the label, this is correct, reject the label, does not fit the text, or ignore it, skip it because of any reason. And that's kind of the whole decision that the annotator should do, and this is what you should strive for. You should strive to have simpler tasks which the annotator can do one after another quickly. And in order to do this, you will have a lot of different annotation tasks because you might have a lot of things you would like to annotate. So you'll need flexible tools. Prodigy, for example, provides you with a lot of different UI components like labeling or part of speech tagging, image labeling, etc., and database connections, so you can write your data, and all you need to do is just to define where to get the data from, how to iterate over it, and that's all. So use these flexible tools. Do not reinvent the wheel and create your own UI, your own database connection, your own logic for annotation. There are tools out there. Prodigy is a paid tool. I would not say it's worth every penny because I don't know how many pennies you have in your pocket, but it's worth quite a lot. So try this. You can also try Docano, which is an open source tool, or even Google Spreadsheets. It's a flexible UI. It's a familiar UI. It might be suitable for your needs. Okay, so we have a tool, we have guidelines, we think everything is great. Now we want to test that what we think are the guidelines, are really what any other would think is correct. And in this case, we need to check the agreement with a colleague. So take a teammate, annotate the same logs, the same examples as he or she annotates, and then, for example, put it on a heat map. You can see very clearly that the diagonal are the examples that we both agree on. So there are numbers there, and the color also indicates the number. So we can see we have a pretty nice agreement, but we can also see that there are a little bit lighter colors for some columns and rows, which means disagreements on different labels between me and the other annotator. So you should take these examples, discuss it, understand what was confusing in the guidelines because you wrote them for yourselves, and many times it's not very understandable by others. So see if this is see what is confusing in the guidelines, change them, and then iterate. Take another teammate, annotate with him or her, and see that your agreement rate goes up. So this is a visual way to check agreement, but there is, of course, the mathematical way, which we all should try and use. So an agreement score is very basic. It's just how many examples we agreed upon out of the total number of examples, and it should be high, at least 80%. But many times and for many tasks, you need a different, more sophisticated metric. For example, let's assume you have 90% of your data labeled 0 and 10% of your data labeled 1. I could just annotate everything with 0 and probably get to 90% agreement rate, which is not what we want. So things like Kappa score enable to take into account like the prior distribution of labels and kind of normalize the agreement rate according to them. You might have a different problem, and in these cases, you might need different metrics. So you have coherence kappa, slices, and a full handbook of inter-rater reliability to read and digest. So we iterated, and our guidelines are perfect, and everybody understands it's the same. Now we need to scale. So at first, the best option, in my view, to scale is to use internal annotators. They know your world, they know your domain, they're part of your company, so you can talk with them and introduce them to your world, to your product, to the problem that you're trying to solve. Like, what are these annotations going to be used for? It will help them annotate. Then, of course, you need to check the agreement with them, between themselves, and also the agreement between you and them. And if you're satisfied, they can start working and really creating a lot of annotations in a short time span. You need to be responsive, create some kind of group chat. When they have an example that they're not sure about, let them post, answer immediately so you can iron out any disagreement that you might have as soon as possible, so you will have the cleanest data set at the end. Also, it's good to remember that they are seeing a lot of interactions between the users of your product and your product, and they might have insights or feedback or something that they see that could be done better. They are a valuable asset of your project once you have internal annotators. So treat them like valuable assets. Share the results. You have a model, maybe they annotated thousands of logs, you have 99% accuracy, your product is perfect, everyone is happy, they are part of your success, and make sure to share the credit with them and the results. And of course, keep iterating. Always, because annotators may change, they may forget the guidelines, your data may change, maybe you do something different and people are answering differently to you. So always keep iterating and checking the agreement. Okay, so this is the second part, how to scale internally. We talked a little bit about having good tooling and then doing multiple iterations over the guidelines. Getting a good agreement metric, both in terms of performance and in terms of like how it suits your data, and treat people as people, not as CPUs. Even if their salary is lower than yours, treat them nicely because they're part of your success and they're more important than you in many cases. Okay, now we will talk a little bit about unbalanced data. So a lot of the times we have a target class which is very rare for us. So now we'll try to revisit the different stages that we had and see what we should do differently in order to handle this new situation. So many people ask our chatbot, are you a bot? Are you a human? They're kind of confused. It's not a lot of people. Let's assume it's like 5% of the people, but we do want to answer intelligently for to these people. That we are a bot, basically, and they should expect some errors, not much, hopefully. And if we will annotate the data sequentially, it will be very repetitive and very boring. It will be like, no, 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 yes, no, 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 and probably you will make mistakes. You will miss some yeses somewhere in the middle, and your work will be suboptimal and your annotation would just waste more time than it needs to. In this case, we are using active learning. So active learning is a methodology. It's not something that is a specific mathematical formulation, but the idea is we're using some kind of model to select the interesting cases that we want to annotate. So instead of like annotating all of the different highs and hellos and goodbyes and thank you that the user say, we will just annotate the sentences which seems to be like, are you a human or are you a bot? How we choose these sentences, how the model chooses these sentences can vary. So usually there is some metric of uncertainty. It might be probability. If you have a probability for a class, then everything around 50% is uncertain and you want to annotate it. Maybe it's some kind of information gain. Like the model says, well, if I know the label for this example, I will be able to have a much clearer boundary for myself. So it might be this information gain, but basically some kind of uncertainty. In addition, it doesn't have to be like a machine learning model. You can use for filtering some kind of like regular expressions or some kind of like different non-ML model to just filter out the data that is interesting for you to annotate. In this case, we can use like a regular expression, simple regular expression of either the word bot or the word human appears in the sentence. Now, the classic approach for active learning is you have the model inside the loop. Every time you annotate an example or annotate a batch of examples, the model updates itself with the new labels, and then its uncertainty scores might change, and it will output a new bunch of examples to annotate, so which are the most uncertain every time in a loop. It's a very nice idea, but many times it's not feasible. Many times training is slow. You can use offline filtering. Just use a model to get the interesting cases and let go of the uninteresting cases. It doesn't matter how you do this. You can do this filtering or sorting offline, but do use a model in these cases if you don't want to waste your time and your annotator's time. A caveat that you have with active learning is that the annotated data that you have will be skewed towards some specific class or specific examples. In our case, if it's a regular expression, all of the sentences will either contain the word human or the word bot. So your model might have a hard time generalizing from this data set to the general distribution of messages, for example, that the chatbot sees. So understanding how to train it is one problem, which we will not touch upon, but it's a good practice to understand how it affects your accuracy. Because if you evaluate your performance metric, let's say accuracy, on the skewed data set, it doesn't represent the true accuracy that you have on the general population of messages that you get to the chatbot. So the easy solution is just annotate a test set sequentially with no model in the loop and keep this test set aside for evaluation purposes. The more elaborate solution is to use some kind of estimation, a balanced accuracy score. You usually need to sample a little bit of examples from the majority which the model does not want you to annotate, and then scale it using inverse propensity weighting and or something similar. So there is a lot of literature about this, and it still depends on the situation. But do think about it when you use active learning. So active learning, as we said, it enables you to do faster annotations, better annotations, using a model in the loop, whether actively in the loop online or just differently offline. But you need to be careful about your evaluation and about your training in order to do this right. Now we will move on and talk a little bit about external annotation services. You might be tempted to use them because you don't have internal annotators, or you just need more throughput for your annotations. You need a lot of data in a short time span. And there are a lot of options out there. So Mechanical Turk is probably the most famous one, but there's also Figure 8 or SageMaker Ground Truth, which is based on Mechanical Turk. There are a lot of APIs out there which make it easy to scale out. You just create some kind of a web page, and people are being paid like a penny or 5 cents or whatever per annotation task, and you can get a lot of annotations in a really short time span. However, it's very hard to get good results because the annotators are very new. They don't know your domain. They change every day. They go online and offline. And it's sometimes really hard to get a clear results from this. So I would suggest you to save this kind of annotation for simpler tasks, something that you believe everybody can do. If you have a more complex task, like transcribing audio, it's not suitable, in my view, for external annotators because it requires a lot of proficiency. If you have external annotators, you many times need to change how you present the annotation task. So let's assume I have 20 categories of different answers that I would like to answer for the user. I have 4 pages of guidelines. I'm not any external annotator gonna read 4 pages of guidelines. It's just not worth it. They will not do anything. So you need to be creative and create some other annotation task, which is a proxy to what you really want to get. So an example would be to show what the user has written, like what is the total price, including taxes, and then show them a possible answer. So not the category like payments or price. Show them the full answer that you would like to show the user and ask them, is this answer really good? Does it answer the user's query? And then using a lot of annotators, you can try to have some kind of estimation as to what is the label that you really want. You can also show, for example, a few different answers and ask them to choose the best answer for this specific question. But then you need to think about how you choose your candidate set. You have 20 categories. You won't show 20 answers. So a lot of thinking and a lot of creativity around how you create your annotation task for external annotators which are unproficient. Maybe the most important thing about external annotators, they are noisy. They work quickly. They need to get things done. They not always understand the task because they are not part of your domain, and they make a lot of mistakes. So you must use multiple annotators per task. Always, never do anything else. But the golden rule is use 3 and take a majority. But this is usually not enough because let's assume that 1/3 of your answers are incorrect for any reason, then 1/4 of your annotations would be wrong. And having a data set where 26% of the examples are labeled in the wrong way is a very noisy data set. So use more annotators, use kind of overwhelming majority, like 6 out of 7 annotators or something like this. Invest the money to get more and more data because the data is noisy, and having more of it will enable you to denoise the signal that you get from the external annotations. Also, a nice thing is you can many times check personally for annotators that have good agreement rates with other annotators or bad agreement rates, and then ban the bad annotators and ask to have more time from the good annotators. So it's also a good practice to use if you're using an external annotation service. So this is the external annotations. It's a different scenario. It might be worth to try it, but you need to adjust the task, be creative, and monitor always without compromising. Always be very tuned to what's happening with your data. The key takeaways. Annotation is not a one-off. It's an iterative process where you need to go over the guidelines and revisit your definitions over and over again. You should be methodological. It always delivers quality. There is no other way to make sure that everything works fine. Communicate what you have in your mind, what your task is, what your labels mean. Do not assume that telepathy works because other people will not understand you. And don't reinvent the wheel, even if it's unfamiliar for you, even if you never ever use some kind of annotation tool. So get familiar with this and don't reinvent it. That's all. You can get in touch. This is my email. This is my LinkedIn. If you need a password like the email for my LinkedIn, this is the email. And thank you very much.